In this video, we'll be talking about Multimedia Sciences Gas Laws Lab software. First thing that we'll look at is a very quick overview of the four variables that have to do with the gas laws. There's pressure, and every single time that a molecule or an atom hits the sides of the container, it increases the pressure. Volume, of course, we can change the volume of the container in a number of different ways. Temperature, if we increase the temperature, the molecule moves more quickly. And if we decrease the temperature, it moves more slowly. And of course, if we add mass, we're basically adding more atoms and more molecules. So it's a very simple discussion of exactly what these four variables mean. Next, the software will go through 3 experiments that will allow students to come up with the final PV equals nRT equation. The first one is pressure versus volume. A little discussion. And here is our experiment. As you can see, we've got a number of molecules that are bouncing around inside of a container. We can change, we're doing pressure versus volume, so we can change the volume up and down. And then what we do is we take the pressure by measuring the hits per time. And it's every so many seconds we can take a reading. And then we can use this information as our data. And then we'll change the volume. So the volume goes down to 12. We'll take another set of data. So what I found very interesting when I made these simulations is that it does take time for the simulation to reach equilibrium. This is not pre-set up. These are actual simulated molecules bouncing around. So when you change the volume, it takes a little while for the pressure to reach equilibrium. So if you took the values here, you'd see that it starts out at the old value and then slowly increases. And so that's why there's this flashing text to say, take a little bit of time before you start taking your data. Next one is pressure versus temperature. Now we see that the volume will stay constant, but we can increase the temperature. And again, each time we increase the temperature, we can measure the pressure by taking the hits per time. So this will be our 2 points of data, our temperature and our pressure data. And we'll graph that. I like the fact that you can see, the students can see exactly what's really going on. They can see the molecules in motion. They get a real good idea of what it means when you increase that temperature. And finally, we've got the volume versus pressure. So in this case, the pressure will be held constant by the weight that's pressing down on the molecules. And we'll be doing volume versus temperature. Same thing, we'll be measuring the hits per second as our pressure. And what will happen is we increase our temperature, the molecules will hit the weight more often, and they will cause the volume to change. In this case, as the temperature goes up, the volume should increase. So in this case, when we find that the pressure has come to equilibrium, back to our 50, we can now take the value of the volume of the container from the scale on the side. And then we'll keep doing that. Again, you'll see that this will go up. And again, we've got to wait until the pressure reaches equilibrium. So I think these simulations do a really good job of showing also how experiments reach equilibrium when you change one of the variables. So that's the software. There also are lab reports and answer keys that are provided. Let's take a quick look at those. These can be accessed from a menu that is also provided. So here's an overview of the materials, which is some of what I've just gone over. There's a lab write-up in Word and PDF format, and then of course an answer key. Let's just take a look at the Word. So this is the experiment handout, in this case with the answers included. You can see that there's a number of questions on each experiment talking about the independent and event-dependent variables. And there's a description of how to run the experiment, a data table, and you can see here is a set of data that was taken from the simulations, the 3 experiments, and then there are some graphs. And the final question is, what would be the final relationship that you would come up with from the answers for all 3 of the experiments? So that's the gas laws experiment from Multimedia Science. So if you're interested in finding out more about the gas laws experiment software, or if you'd like to look at the other materials and software that is available by Multimedia Science, please go to Teachers Pay Teachers at this URL. Thanks.